Hello and assalamu alaikum to everyone. I welcome you all in this new animated English lecture videos, and today's topic is Newton's law of motion. We will discuss first, second and third law of motion of Newton, okay? Newton's first law of motion states that a body continues its state of rest or of uniform motion in a straight line provided no net force acts on it. That means if an object is at rest, it will remain at rest unless someone applies force on it, moves it, okay? And if a body is in the motion or in the uniform motion, it will remain in the motion unless someone applies force and stops it. Let's discuss some examples. So the first example is a ball roll on a rough surface will stop earlier than the ball roll on a smooth ground. This is because rough surfaces offer greater friction. If there is no force or friction to oppose the motion of a body, the moving body will never stop. That means if we roll a ball on the rough ground or rough surface, there will be friction to stop and to oppose the motion of that ball. But if we are rolling the ball on the smooth surface, there is no friction or there is no force that is opposing its motion, then the moving ball will never stop. Example number 2 is when there is a book on the table. It is at rest, okay? It is not moving by its own self, okay? But if someone applies force and moves it, obviously it will change its position. But otherwise, it will remain in the rest position. Example number 3 is, if there is a glass on the table and it is filled with water, someone tilts the glass and water will flow on the ground. What it means? That means the water and the glass are in the rest position, okay? They're not moving. But if someone applies force, the glass will be tilted and the water will flow on the ground. Since Newton's first law of motion deals with the inertial property of the matter, therefore Newton's first law of motion is also known as the law of inertia. So the question arises that what is inertia? Inertia of a body is its property due to which it resists any change in its state of rest or motion. It is a property of an object due to which it moves, it stops, it flies, or whatever it does. It is due to inertia. So now we will discuss the Newton's second law of motion. So the Newton's second law of motion deals with the situations when a net force is acting on a body. It states that when a net force acts on a body, it produces acceleration in the body in the direction of the net force. The magnitude of its acceleration is directly proportional to the net force acting on the body and inversely proportional to its mass. That means if someone applies more force on the object, there will be more acceleration. Do you understand? That if force increases, acceleration will also be increased. So acceleration is the change in the velocity. Acceleration is inversely proportional to the mass. If mass is small, the acceleration will be more. Acceleration is directly proportional to the force and it is inversely proportional to the mass. Its mathematical expression is F is directly proportional to m into a. If we put equality sign instead of the proportionality, then the constant will come, it is k. K is equals to 1, so if we multiply 1 with m into a, then the final expression is F is equals to ma. So now we will discuss the SI units. 1 Newton is the force that produces an acceleration of 1 meter second square in a body of mass of 1 kg. That means a force of 1 Newton can be expressed as 1 Newton is equals to 1 kg into 1 ms minus 2. And 1 Newton is equals to 1 kg ms minus 2. This is its SI unit. From this derivation, we can say that we have found the unit, the SI unit of force, which is 1 kg ms minus 2. Now we will discuss the examples. Example number 1 is, if a man is moving a big giant rock, it is applying net force on it. Obviously, the rock is so much giant that it is very difficult for him to move it. So that's why it is applying more force, more net force. And acceleration will be produced lesser. What does that mean? If we apply more force, there will be more acceleration. But if the mass is greater, then the acceleration will be less. So, if a man is moving the smaller rock, it is applying more force. In this, we can say the mass is smaller. So, what will be happened? If the mass is smaller, then acceleration will be more. But if we are applying more force, there will be more acceleration. Now it's time for the Newton's third law of motion, which states that to every action, there is always an equal but opposite reaction. If a box or the block is hanging with a string, then what we see that it is at the rest position. But why? We can't see or we can't think that there must be a reaction or action force. The force which is acting upward towards the string, it is tension. What is this? It is tension. It is action force. The force which is applied first, it is action force. But in the reaction, the weight or another force will be applied. The weight force will be called as reaction force. That's why tension and the weight will cut each other and there will be no effect or the motion will not be produced. That's why that block will be at rest position. So let me discuss another one example. Take an air-filled balloon. When the balloon is set free, the air inside it rushes out and the balloon will move forward. In this example, the action is by the balloon that pushes the air out of it when it's set free. The reaction of the air which escapes out from the balloon acts on the balloon. Consider another one example of rocket that moves on the same principle. When its fuel burns, hot gases escape out from its tail with a very high speed. The reaction of these gases on the rocket causes it to move opposite to the gases rushing out of its tail. So that was the action and reaction happening in the rocket that causes the motion in the rocket. So that was it for today's lecture. Hope so you like it and it is helpful for you. You can tell me in the comments below which video or which topic do you want next. So if you want more, subscribe to my channel. Thanks for watching.